Hello everyone. Welcome back to the course of Finite State Machines. This video is brought to you by Newton's Group of Institutions, Macharla. This is Yegireddy from the Department of Computer Science and Engineering. Now, in this video, let us see how we can convert a regular expression to an finite automata, whether it is a non-deterministic automata or deterministic automata. So, by taking the regular expression, we can convert whatever the way we want. So before seeing the examples, let us see the process of converting the regular expression to an finite automata. So to convert the regular expression to finite automata, we use a method which is called as an subset method. So with the help of subset method, we are going to convert the regular expression to an finite automata. So the steps are whatever the regular expressions that is being given, we have to design a transition diagram for given regular expression using non-deterministic finite automata with epsilon moves. Okay, so first thing is we have to design a transition diagram. Whatever the regular expression is given, for that we have to make a non-deterministic finite automata with epsilon moves, because empty moves will also be there for the regular expression. So we have to convert the NFA with the epsilon moves. After that, we have to convert the non-deterministic finite automata with epsilon moves to non-deterministic finite automata without epsilon moves. So we have to convert the non-deterministic finite automata with epsilon moves to non-deterministic finite automata without epsilon moves. And finally, we have to convert the non-deterministic finite automata to an equivalent deterministic finite automata. So these are the steps that we need to follow. So here the regular expression is converted to non-deterministic finite automata with epsilon moves. After that, we remove the epsilon moves, then we get non-deterministic finite automata. And finally, we have to construct a deterministic finite automata. Now, let us see with examples. So what we can, so that we can easily understand how we can convert a regular expression to an finite automata. So first, let us see how we can convert a regular expression to non-deterministic finite automata, NFA. If we have a regular expression A or B, then it can be represented by using two states and two transitions between these two states. One transition is A and the other transition is B. And if we have a regular expression AB, then it will have three states with the two edges between them. So we have three states and two edges between them. First transition is A and the second transition is B, which follows the first transition. And finally, we have a regular expression A star. Then it will have four states. Okay, so A goes between the two middle states and epsilon transitions on the other states. So these epsilon transitions forms 0 or more A's. And here the direction is the most important. Okay, so here the directions are the most important thing. Now, let us try to solve some regular expressions. For example, we take a regular expression x or yz. So this we can represent like this, x as A and yz as B. So here we can represent this by using two states and two transitions between them. First transition we label with x and the second transition we label with the yz. And in the next, we have to break down the yz into back-to-back components like this by including one more state in between and represent the transition like this. So here X or YZ is converted into NFA. Okay. Now let us try with one more regular expression, W or X whole star. So we can treat W or X as A. So we can represent this using 4 states, middle one which represents Y or X, and first and last get the epsilons, and we put other epsilons over here. So here now the middle one which becomes two transitions, that is one is W and the other one is X, and the 1 to 1 on the left is a starting one and the other on the right is the final state. So here this one is one on the left is an starting one and this is the final state. Now let us construct a finite state automata for the regular expression A or BB star BA star. So now here we have to follow certain steps while converting this. This is a bit complicated regular expression. Now let us see how we can construct the finite automata for this particular regular expression A or BB star BA star. So in the step 1, here we need to convert the regular expression into the transition diagram. So here this is our initial state and this is our final state. Now let us first construct A plus BB, then A plus BB star, then A star, and then we need to concatenate A plus BB star BA star. Okay, so now let us first construct a transition diagram for A plus BB. So this is how we can construct a transition diagram plus A plus BB. Now let us construct a transition diagram for A plus BB star. So here we get 4 states, and the 4 states, the 2 states front and back must be an epsilon, and one transition from end to A with an epsilon move and the other transition with an epsilon move. So here when we construct with A plus BB star, the meaning is there can be 0 or more than 0 A plus BB strings. So this is for A plus BB star. Now let us see how we can construct a transition diagram for A star. So already we know, we have seen how we can construct a transition diagram for A star with 4 states. So this is how we are going to construct a transition diagram for A star. Now here we have to concatenate A plus BB star, B and A. How that is done, you see. So here we are adding B to it. Now by adding this particular initial state and the final state to this particular transition diagram, we are going to get a non-deterministic finite automata with epsilon moves. So this is my initial state and this is my final state. So this is the non-deterministic finite automata with epsilon moves. Now the same thing in my next video, I will explain how to convert the regular expression using Thomson structure. So in Thomson structure, for each and every string, we are going to use an epsilon. So that we will see in our next class how we can. And we will also discuss about how we can convert this particular regular expression to deterministic finite automata. So to convert this into finite automata, The finite automata is nothing but it can be either a non-deterministic finite automata or a deterministic finite automata. If in your exams or any questions, if they ask you to convert that into a finite automata, you can leave like this. Or sometimes they will give a regular expression and they will ask you to convert to deterministic finite automata. Then what you have to do, first step, you have to draw a transition diagram. Then you have to convert the transition diagram into deterministic, non-deterministic finite automata with epsilon moves. Then you have to convert that non-deterministic finite automata with epsilon moves to non-deterministic finite automata without epsilon moves. And now you have to convert the NFA to DFA. So we will see the remaining part in our next video. Thank you very much. Thank you. If you like this video, please subscribe to my channel and press the bell icon for the latest notifications. Thank you.